3D bioprinting. 3D bioprinting is an advanced technology that combines 3D printing with biology to create three-dimensional living structures, often using human cells or other biomaterials as bioinks. It has significant potential in various fields, including regenerative medicine, tissue engineering, drug testing, and disease modeling. The process of 3D bioprinting involves several key steps. 1. Bioink preparation. Bioinks are biocompatible materials that contain living cells, growth factors, and other components necessary for the development of tissues. These bioinks can be based on natural materials like collagen, gelatin, or alginate, or synthetic polymers that mimic the extracellular matrix of the target tissue. 2. 3D printing. A 3D bioprinter uses computer-aided design (CAD) models to precisely deposit layers of the bioink, building the desired three-dimensional structure. The printer can follow predefined patterns and control the placement of cells, creating intricate and complex tissue architectures. 3. Cross-linking or solidification. After the bioink is deposited, cross-linking or solidification methods are applied to stabilize the printed structure. This step is crucial to maintain the shape and integrity of the tissue construct. 4. Maturation and tissue development. Once the bioprinted structure is created, it is placed in a controlled environment, such as a bioreactor, to allow the cells to proliferate, differentiate, and mature. This process helps the tissue develop into a functional, living organoid or construct. 3D bioprinting offers several advantages over traditional tissue engineering techniques, such as greater precision in creating complex structures, the ability to customize tissues for specific patients, and reduced reliance on animal testing for drug development. Potential applications of 3D bioprinting include 1. Organ transplantation. 3D bioprinting holds the promise of creating patient-specific organs, reducing transplant rejection rates, and eliminating the need for organ donors. 2. Tissue engineering. It can be used to generate tissue replacements for damaged or diseased tissues, such as cartilage, skin, and bone. 3. Drug testing and development. Bioprinted tissues can mimic the human body's response to drugs, enabling safer and more efficient drug testing. 4. Disease modeling. Bioprinted tissues can serve as accurate models for studying various diseases, such as cancer and genetic disorders. Despite its potential, 3D bioprinting is still a developing technology with several challenges. Ensuring the long-term viability and functionality of bioprinted tissues, addressing the complexity of vascularization to support larger structures, and scaling up production are some of the areas that researchers continue to work on. Nonetheless, 3D bioprinting holds enormous promise and may revolutionize healthcare and personalized medicine in the future. Don't forget to like, share, and subscribe for more exciting content on the latest technology trends and innovations. Thanks for watching.